with the next speaker. And it's the same subject area, generally, digital light planning. The next item is on automation of light planning in the BIM and AI context. We'd like to welcome Robert Heinze from Relux Informatik. Welcome from my side, and thank you for the opportunity to tell you something about light planning and automation. I'm Robert Heinze, working for Relux, and I used to work for a big manufacturer and looked about light planning, anything to do with light, basically. It's a nice way to pick up from the preceding speaker. So BIM is something which I've followed for years, also in the field of standardization. And as of today, it is very possible to use several types of software programs to do digital planning. Digital light calculations are possible to do, also using Open BIM in IFC. That's a real-life IFC, which was calculated and computed where the data are so transferred. And that's possible today. It's not always it's not always seamless. That is, of course, I have to be honest there, but we're getting better there. I would recommend to take an IFC and do it. We have made progress in recent years. Now, BIM light planning. There are a number of digital luminaires. We have a new format for that called GLDF. Just recommend this to all the manufacturers to take a look at this format and to publish their data on their luminaires, which gives us an open and complete standard to describe luminaires with the geometry and the light exit and so on. Which is really completely covers a luminaire digitally. This should be used, GLDF. It is publicly available. And it goes across different software programs. Then, as we've heard from Jake Jacob in the presentation, there is a fresh paper about LOIN. This has been published recently. You can find it at licht.de. And you can see all these tables which we've seen with the allocations, which feature is good for which application. And this can be downloaded free of charge from licht.de. And you find the granularity which you need. You need LOD and LOIN in order to know how many how many data you need. It's not good to have too much data or too little data. It's difficult to get the quantity of data right, and this helps us to improve communication. And the presentation we've just heard was about this aspect, digital light planning process. And this exists, it's living, it's breathing, it's continuing to develop. And this has been a contribution by ZVEI and licht.de to really come to summarize this. I can only recommend this. It's free of charge, you can download it, and you can apply it. And talk about it with all the planners involved. Let's talk about AI. There are interesting AI tools available. I'm going to show you a small video now. This is an AI tool which can detect rooms from PDF. The planners know that you have to first of all try to find out what are the rooms. And you just upload the PDF. It's a pixel PDF, not a vectorized PDF. So you only have a picture of the floor plan. And this is being tested, piloted, and it's going to be free of charge. So with this tool, it's possible to have the AI detect your rooms and then do a 3D planning. No one has to copy anything anymore. But of course, it's AI. Beware. There are, of course, skewed walls. Some rooms are overlooked. There are rooms which have more than 2 corners. But if you look at these hospitals, for example, it's always a blessing to at least cover all the rooms and then carry on working with it. Well, of course, you still have to name each room. You have to come up with a usage profile of each room. We haven't reached the end of the line, but it's the first step to make it easier for planners to use data and detect data and create data and carry on working with it. Now let's talk about the actual subject of my presentation, which is automation of light planning. This, of course, only applies to normative planning. It's only works based on room by room and only depending or based on a standard. It is not creative design. It's not about beautiful light. It's just the light which you need to fulfill the norm. The norm is a standard called 12464, which also considers light quality, not just to say I need 500 lux or something, but also the reflections on the walls and the ceilings. This has also been included there in the standard, and these are idealized data sets, idealized in order to get the values right. This can only hit the right values. Whether the light is then beautiful, the light design rather is beautiful, that's an all another question. But the way it works is we have a filter process. So I have the digital building, which is very important. All these rooms need to be digitalized. I need an NFC. I need an AI, which detect the rooms. I need the users' profiles of these rooms. I need to know this is an office room, and this is a toilet, or this is a lobby or something, so as to get the target values from 12464. The next thing is called a pre-filter. So the data have to be allocated to luminaires. If you have unlimited computing power, you can take a look at all the luminaires there are. Relux net has 1 million luminaires in its database, but that would be too much. So we have a pre-filter where you can filter between 20 and 200 luminaires, depending on profile. So these 20 luminaires are good for an office. These other 20 ones are good for a corridor. And then you allocate a luminaire to each room, and also you compute the right location in order to fulfill 12464, and then you get a group of results at the bottom. So for each luminaire, I have a diagram which tells you each blue line is a luminaire in this room, and it says that's okay. I've got a number of luminaire numbers. I have a range of illuminance, and from this group of results, I have to decide which is the best solution. Do you want to have the cheapest solution? Is glare the most important? Is it about beauty? Do you need the luminaires next week? So delivery time is an argument, can be a factor. So I have to need to know what the lead time is for a luminaire, so that I can then show this on these diagrams. And when I've done that, all that, I have a post filter, and then I have a light planner. And this is something which the light planner can hand in and say, I have met the standard. I'll give you an example of this. This is a tool which we developed for Sonnepaar. So the user can use this. This is the pre-filter. Each room has been allocated a usage. I've done this in this case. And then we have luminaires which match this usage. We have a standard set for Sonnepaar for corridors, one set for all toilets, and these are allocated to these profiles. You can do it yourself also. You can pick luminaires which you'd like to have for a toilet. It must have a certain color temperature, must have a certain size or a certain price or something. I can pre-select it. And then the computer does thousands of computations with the Relux core. And then, as a result, you get a bill of material, which covers the whole building, in this case, the whole story. And these sets of luminaires can be sorted by classic would be price or light quality. For light quality, we have a scoring system, so which has more parameters. For example, glare is more important than modeling, or that's more important than uniformity, with a weighting factor. And the total score can then be sorted at the user's level. Give me the best light quality depending on my preset criteria. That's in the background. And then I can pick the technically best solution from the whole context. And this bill of material goes back into the PDF. And with a further click, It is in the Sonepar um, um, catalog. So it's a kind of self-service for light planning, but it's good for the normative approach. It's just these are the luminaires and which you need to meet the standard. That's the main thing. And then you get a list, and with the color coding, what is the uniformity, the glare factors, with this, what does it look like for each room? So then I have at least a first iteration. Now, this year we're going to develop further products which also use this core optimizer, very online solution where you can have an IFC or a PDF for the rooms, and then you have a selection of luminaires for the usage profiles, and you can automate the calculation for each room. So much for the mathematical level. I'm sure in the next few years this will improve the light planning process, so all the boring stuff can be handed over to a machine when it comes to dimensioning how many lumens with which products and which places do I need in order to meet the standard. No more, no less. The other point is the visualization of light planning. There are new methods there. We call it real-time rendering. This is Enscape. Enscape is a visualization product by colleagues from Karlsruhe, and we cooperate with those colleagues. We are allowed to use the Enscape engine. And with this rendering, we get a 3D model. This is an IFC input. I didn't change anything about it. It's just an IFC, which I found at GitHub, which is free. And I can use daylight, I can use artificial light, I can visualize the building. It's a lot of computation because someone has to do the IFC, someone has to model all these chairs, which is a lot of work to do this. But of course, the visualization does mean some work. What I can do with AI, most of you will know that at the top of the left we have a Relux light density rendering. That is the sort of run-of-the-mill rendering without any furniture or plants or textures. So this is the result of easy lux if I want to have 300 lux on the floor. So we can see the illuminance there, and you can also put this into AI tools, and you prompt it to say, can you give me a coffee shop scene? Can you give me a daytime scene or a nighttime scene? Can you add some people there? And surprisingly, I was very skeptical, but the light distribution is quite realistic nowadays. This is quite a new tool. Nano Banana, it works quite well, but I was very skeptical. Even the shadow on the furniture is quite realistic. So to give you an impression, I think it's quite good. It is a kind of, a suggestion, of course, not exactly right. It could be a suggestion. It's like if you buy a product and on the tin there's a photo of the actual finished meal, and it's not really. It's got some decorations on it which are not really realistic. But it's the first impression. You can save a lot of work by doing an AI rendering. However, this costs about 15 cents, depending on the resolution. But you're done very quickly in the space of a few seconds. You can do this rendering. I've brought another example, a simple VLUX which doesn't even have windows, and I tell the AI, please turn this into a lab for me, with a nighttime scene, daytime scene, with windows, without windows. We also enter the dimensions of the room, the 3D geometry of the luminaires. We give the pictures of the luminaires, and then we get these results. So considering the effort we have to do with this, it's quite helpful, and we try to integrate this into our application, how to do these renderings, the AI renderings, have good prompts in the background, and then allow the user to do the prompting himself or herself, and then this would be a quick and fast and easy way of getting some rendering. And that's it. And if you want to have more information, just go to the licht.de stand. You get more information about also my contact data. Thank you.